The envelope detector consists of two main components. One is a square law device. You could also use an absolute value for that. And the second is a low-pass filter. I'll begin by creating the control for our modulated signal input. This is of the waveform data type. Now I'd like to be able to work with the actual sample values as simply a 1D array of double. I can pick that off from the terminal labeled Y. Really, you could use many different types of low-pass filters. I'll just land on the simple Butterworth filter. And a second order filter will probably work nicely for that too. We see that we can choose the specific type of filter. We can apply our inputs. We need to provide the sampling frequency. And we also provide corner frequencies and the filter order. Now, various built-in subVIs expect the sampling frequency to be somehow related to a normalized sampling frequency. Other times it's specified in hertz. Looking over the documentation here, it doesn't exactly come out and say that sampling frequency is in fact in hertz. But if we look at the corner frequencies, we read things like a default value of 0.125, and that would suggest that the normalized sampling frequency is 1. But it simply says that we just need to set it up to be in an appropriate relationship to whatever we call the sampling frequency. So I'll come back to that in a moment here. So again, we need a low-pass filter, and I've defined that for our filter type. Now, of course, DT, that's our time step or sampling interval associated with our waveform. I can then recover the sampling frequency by taking the reciprocal of our time step. And here I'm fashioning the square law device, but again I'm using an absolute value for that purpose. Now the corner frequency of our low-pass filter can be specified in terms of hertz. Also, the order can be specified too. Now I need to ultimately generate the demodulated result as a waveform data type as well. This is an easy way to do that. This picks up the sampling interval, passes that through, because really the waveform data type is nothing more than a special type of cluster. Then we attach the new thing that we want to specify for the actual signal. And at that point we're all done.